Thank you much. Thank you very much, Olivier, and good afternoon to everyone. I am Robert Pinter, Market Development Manager at International Copper Association Europe, and welcome everyone to the 14th webinar of the Zero Emission Buildings Academy. We organize this academy and this series of webinars in partnership with Building Performance Institute Europe and the European Construction Technology Platform. The aim of this academy is to share information and knowledge related to decarbonization of buildings and promote the transition to a zero-emission building stock. Each webinar, as you may know, invites experts to deep dive in one specific aspect that is relevant for this transition and offers also enough time for questions. Today, our subject is shaping national building renovation plans, addressing policy needs in focus countries. The EPBD recast introduced the definition of zero-emission buildings as a highly efficient buildings with very low energy need, and this low amount of energy is to be fully supplied by renewable energy, preferably generated on-site, if not possible, from the grid. So we know the final status where we need to go, and to achieve this required transformation of our building stock, a lot of planning at building, district, city, and national level is required. And key pillar of this planning exercise at the highest, at the national level, are the National Building Renovation Plans, or NBRPs, to outline strategies of each member state for achieving these objectives. Today's webinar will provide an analysis of the challenges, policy needs, and strategies for implementing these initiatives across 6 focus countries: Bulgaria, Greece, Hungary, Poland, Romania, and Ukraine. And I am very pleased to introduce our today's speaker, Lukas Kranzl, a senior scientist at Technical University of Vienna Energy Economics Group, who will deep dive into country specifics of NBRPs. I stop here with my introduction. Thank you very much, and give the floor to Lukas.
Yeah, thanks a lot, Robert, for this introduction and the opportunity to share some thoughts, ideas, results of the project EPBD.wise. The title of my presentation, as I said, is Shaping National Building Renovation Plans, Addressing Policy Needs in Selected Focus Countries. A few words on the background of this presentation. EPBD.wise is a project funded by the LIFE program, and the project EPBD.wise supports the implementation of the EPBD recast, in particular in the 6 focus countries that you, Robert, already mentioned before. And the deep dive into 5 key elements of the EPBD, which either were introduced as new elements in the revised EPBD or which changed their ambition level, their meaning, their way they interact with other policy elements. And these 5 elements are national building renovation plans, minimum energy performance standards, and national trajectories for progressive renovation, energy performance certificates, building renovation passports, and zero-emission buildings. And they are obviously all linked to each other. They cannot be really seen separated. And all of them are somehow covered and provided in a consistent way in the national building renovation plans. And this will be the main topic of my talk today. Where do we stand with our project? We first worked on on the question, what are really the policy needs? What are the challenges in selected European member states to implement these new innovative elements of the EPBD? And what are also best practices for each topic? And these reports can already be downloaded from our project website. And we have now entered into the more intensive policy support phase, where we are working on drafting policy guidelines specifically for the focus countries, but in parallel also preparing their application of the results to EU 27. The project started in October 2023 and will last until June 2026. So we are approximately in the middle of the project now. So now to the topic of national building renovation plans. According to the recast EPBD from earlier this year, national building renovation plans will need to include an overview of the national building stock for different types of buildings, a roadmap with targets for 2030, 40, and 50, including measurable progress indicators, implemented and planned policies and measures supporting the implementation of these roadmaps, and outline also what are the needed investments, financing sources, and what are the measures to make this financing happening, and what are also administrative resources to implement the roadmaps, the national building renovation plans. An important element are also minimum energy performance standards for non-residential buildings and national trajectories for residential buildings, and much more. The EPBD lists all the elements in a quite high level of detail, and soon the European Commission, DG ENER, will also come up with a template how to prepare these NBRPs to make sure that they are also consistent, they are comparable, and include all the required information in a consistent way. The NBRPs need to be submitted every 5 years and should be also part of the NECPs, and that sense also be consistent to the framework of the National Energy and Climate Plans. The first draft NBRP needs to be submitted by end of next year, and then the final NBRP by end of 2026. So this means that actually now is a crucial time to prepare these steps, the required data, the methods, the processes, because not so much time is actually left for submitting, for elaborating them and submitting them. National building renovation plans as a concept are new, but they strongly build also on the concept of LTRS, so long-term renovation strategies, which already have been in place before and were developed by member states before. And from these experiences, we can see there are already some good practice examples. For example, Finland provided a really very good roadmap, including measurable progress indicators. So these indicators are very tangible and can serve to monitor the progress very well. Spain has very solid strategies to mitigate energy poverty. In Slovakia, there was a very convincing procedure of stakeholder involvement and public consultations. And Italy performed very well in building a profound, comprehensive building stock database. So it's not that we are starting from zero, but still there are quite some essential policy needs for setting up these NBRPs. And we carried out a number of expert interviews, focus country group discussions. We had policy forums in 6 member states and 6 European countries on these questions. And by that we found out, and this was summarized by colleague Denisa Diacono from BPIE, that there are some quite specific policy needs for setting up NBRPs, and they can be clustered or grouped according to certain barriers. So, for example, there are technical barriers, legislative and regulatory barriers, fiscal and financial barriers, information and perceptual barriers, and institutional barriers. And each of these barriers can also be translated to a certain specific policy need in terms of what is needed for really setting up a consistent, convincing, a comprehensive NBRP. From the technical perspective, a key point is that a better overview of the national building stock is required. I will focus mainly on that in the remaining part of the presentation, but that's really a key prerequisite. But also then from a legislative and regulatory side, we see that the NBRP, as I said before, needs to be embedded in the rest of the EPBD implementation, and in particular also in the whole energy and climate policy strategy and framework of each country. From a fiscal and financial point of view, it's crucial to identify the most appropriate financing sources, develop tailored funding schemes, and all of that needs to be embedded and supported by effective public consultations with relevant stakeholders, also to have the backing and an agreement as far as possible with civil society, with NGOs, with industry, public authorities. On the institutional level, there is a need to build capacities, both at the local but national level, also for drafting and implementing the NBRP. For some countries, we see that this is already available, but for other countries, there is definitely still a need to build this capacity. And this is also strongly linked to establishing a monitoring, reporting, and evaluation framework for the NBRP. So the NBRP should be really seen as a continuous process, not only as a one-shot document that is submitted to the European Commission, but it should help also to continuously then afterwards monitor the progress and set corresponding measures. So, summarizing, the policy needs as such. First, better data is needed. That's what we have seen from all the stakeholder interviews, from all interactions. We need data to underpin the renovation strategy and planning, in particular for non-residential buildings. And according to the structure and intention and priorities of the EPBD, this needs to address in particular all the worst performing buildings, meaning we need to know what are the worst performing buildings. We need to have the data for the worst performing buildings in order to align policies to target the buildings which are most in need of renovation. But then we also need to establish the measures on the different sectors of the building stock, in particular for non-residential buildings, but also for residential buildings, public buildings. We need specific measures to tackle energy poverty, and all that through data-driven analysis. And last but not least here, what I want to mention is the technical and economic feasibility, which needs to be, on the one hand, ensured by a solid modeling and analytical framework, but then also by a consultation with industry citizens for feedback, as I said before. So I already mentioned we have a strong focus on these 6 countries: Bulgaria, Greece, Hungary, Poland, Romania, and Ukraine. And we discussed with different type of stakeholders and experts in these countries, what do you think are really the challenges for developing NBRPs on member states level? And I don't want to go into detail. I just want to highlight that in more or less all the countries, the question of data on the building stock turned out to be essential. So we need to improve building stock data, but then the question is also which information is actually needed, which granularity, for which purpose do we need the building stock data? And in the coming slides, I will try to highlight the elements which, at least from my perspective, I think will be key to set up this data requirement, this data base for the further development of the NBRP. So first key requirement is the information on the heated floor area and or number of buildings per building type. As a data source, in many cases, we might use building registers, construction permits, but we also know that in many countries, they are either not available or not properly accessible, or even also not accessible in the right format, or they are also not consistent because they may not have been maintained all the time very well. So I expect that in many countries, there is a need also to enrich these data sources by other sources, such as public databases, the Building Stock Observatory, for example, but also databases such as from the Pan-European Heat Atlas or Hot Maps, Tabula, Episcope, also maybe commercially available building data, building shapes, or OpenStreetMap data, satellite images. All that have their strengths and weaknesses. Some of them are incomplete, but from our experiences, it's also necessary to combine different sources to use the strengths of each of these sources to come up with this key requirement of, as I said, heated floor area or number of buildings per building type. Second key information which is needed is the total primary energy use per square meter of heated, cooled floor area. So if we have both of these aspects, so both the primary energy use and the heated, cooled floor area, conditioned floor area, we have the distribution curve of primary energy use per square meter for residential and non-residential buildings. Now, why is it important to have this distribution curve? Article 9.2 asks member states to develop the trajectories for progressive building renovation for residential buildings, and at least 55% of the savings need to take place in the worst performing buildings, which are defined as the 43% of worst performing buildings in terms of their primary energy use. So we need we need this distribution curve, and then by deriving this intersection basically of this with this 43% line, we see, okay, which part of the building stock really needs to be focused on, because here the majority of the savings to take place. Article 9.1 is on the minimum energy performance standards of non-residential buildings. And here again, we will need this distribution curve of the primary energy use to derive the threshold of the 16th and 26th quantile of worst performing buildings. So now we again derive this intersection of the curve with the 16th and 26th quantile line. And then from this intersection point, we go to the y-axis to derive the primary energy use threshold, which buildings need to achieve in the respective target year. So this shows why this primary energy use distribution is so important. But so now, how to derive the primary energy use data needed? Basically, we need information on the heated floor area number of buildings per building type. That's what I already said before, but also then by construction periods. So which vintage classes can we distinguish, and also by the refurbishment status. So what is the share of renovated buildings in different building classes? And this is, according to our knowledge, information which is often missing. So I think here there is a strong need also to improve the data set, and in the short term also to derive sound analytical methods and estimations. And we need information on the heating system. If applicable, in particular for larger countries, climatic zones are relevant to distinguish degree of urbanization, maybe availability of district heating, restrictions regarding renovation, for example, due to cultural heritage and so on. And then, of course, also primary energy factors by energy carrier sorry, are required to calculate the total primary energy use per floor area. So we can distinguish three approaches to derive the primary energy use data. First approach is archetype-based. So what we also could call reference buildings. So archetype-based bottom-up modeled results. What does it mean? We describe the building stock in terms of different reference types, archetypes, describe them in terms of their geometries, U-values, installed technologies. And this, for example, can be done by making use of the data in the European Building Stock Observatory. Second approach are measured energy consumption data for a representative sample of buildings. And last but not least, third approach, EPCs, where again we need a representative sample for the whole building stock. So how could that work? Archetype-based bottom-up modeled results. Here we need data as they are, for example, collected already in the BSO, the Building Stock Observatory. The advantage here is that it's a data collection which is consistent in a common format for all member states. The data is maintained and collected through service contracts and provides and summarizes a wide range of different data sources from statistical offices, reports, scientific analysis, previous projects, and so forth. But in general, it also needs to be enhanced by expert guesses. For example, as I mentioned before, the share of previously performed building renovation activities or the share of heating systems in different categories is often something that needs to be added because it's simply not available in it or not reliably available. And of course, always also consult other data sources such as Tabular, Episcope, or so forth. Now, if we now go decide to choose to go with the archetype-based bottom-up modeled results, how does it work? This graph here shows, on the one hand, the red line, the unobserved real distribution, and as a blue line, the estimated distribution based on archetypes. So typically we see that the archetype-based approach tends to underestimate the variance of the distribution. So we often see that the curve actually is too flat. If we have a look at this 43% identification target of the worst performing residential buildings, it might still be fine, because in this example, at least that we see here, the difference is not too high, about 10%. But for deriving the 16th or 26th quantile threshold for non-residential buildings, it might be a problem to rely only on the archetype-based approach. Why? Because as we can see here, if we rely on the archetype-based approach, we might end up with a threshold, which actually means that not 16%, but in fact 35% of the buildings need to be renovated by 2030. So it's important to also enrich the archetype-based approach, for example, by measured energy consumption data for a representative sample of buildings. The good thing with measured energy consumption is that it's data that can incorporate the actual building usage and consider refurbishment status, climate, all these conditions. If there is a high share of gas or district heating in a region or a country, the data is also available in a, let's say, focused way in a rather small number of utilities or ESCOs that could be let's say, that could deliver this type of data. And then, of course, we need to convert that to total primary energy, but that's usually not the main challenge. But there are also some challenges. For example, electricity, as counted in the EPBD, is not directly measured typically. Also, secondary heating systems often are not included. Data might also contain other energy services, such as process heat, cooking, and so there are also difficulties and challenges with this approach. This also holds for respecting data protection constraints and rules. Also, often utilities and ESCOs do not know the floor area of the supplied buildings. They have a very good knowledge of the energy consumption, but not of the floor area. So also here there are challenges. So let's come, and before we come to the third approach, again, here we can see in red the measured gas consumption per building, and in black the average gas consumption per building corrected by factors such as building type and size, vintage, class, surface to volume ratio. We did that in a European city for about 3,400 buildings. And again, we see a deviation of this real measured consumption to this average gas consumption per building after corrections. But it might be acceptable, the error. And finally, we have the data that could be derived from EPCs. Again, as I said before, it's important to have a representative sample for the whole building stock. The good thing for using EPCs is it includes the required information, so both floor area, heating system, energy use. It's based on a rather common methodology. In many countries, it's stored in one or a few databases. It's in many countries, at least, are accessible. At the same time, we also should be aware that this total sum of primary energy use, as reported by EPCs, most probably is not consistent with energy balances. Many countries, or I would even say most of the countries, do not have a representative, unbiased data sample. Typically, unrenovated, owner-occupied buildings are unrepresented, and we can see that here from an example within Austria, from a city of about 130,000 inhabitants. In this city, EPCs represent about 12 to 15% of the buildings. And looking, for example, on this case of the buildings constructed in the 1960s, we see that there is an over-representation of refurbished buildings. So in general, as I said before, we tend to see in EPC databases an over-representation of newly constructed buildings, multifamily apartment buildings, and refurbished buildings, which also needs to be properly addressed and corrected for. So what are the conclusions regarding the need to improve building stock data? First, we need to derive required data with sufficient quality. It will be challenging for many countries. A combination of the three presented approaches, I think, will be required and also recommended. Archetype-based approaches might be sufficient for residential buildings, but for non-residential buildings, it might lead to inaccurate threshold. There is definitely a need to improve the existing data quality as quickly as possible. I focused in my presentation on the data on the current building stock and building activities and how to identify the worst performing buildings. As a next step, this needs to be embedded in an analytical model, derive policy scenarios, and go into the interaction with stakeholders to finally integrate all that in a consistent way in the NBRP template as will be provided soon by the European Commission. As next steps in the EPBD.wise project, we will now work on the modeling framework for the three countries of Poland, Romania, Ukraine, discuss the scenario settings and possible policy design with country representatives, derive model-based scenarios for the renovation roadmap, and deliver a policy guidance document that should support the member states in filling the NBRP template provided by DG ENER. All that will be supported by a stakeholder discussion process in the first half of next year. And we are also working in the same time on how to replicate this process to EU 27. Thanks a lot for your attention. Looking forward to the questions.